All right, today we're plugging into a topic that feels like it's straight out of the future, using virtual reality to teach in the classroom. Now, the promise is massive. We've all heard the hype. But does the tech actually deliver when it comes to learning?
I mean, you can see the appeal, right? A perfectly simulated classroom, endlessly repeatable lessons, and a totally safe environment to practice dangerous or difficult tasks. It sounds almost too good to be true. So the question is it? So yeah, let's just get right into it. The whole promise of VR in education, the reason everyone gets so excited, is this idea of real, hands-on experiential learning. You're not just reading about something, you're in it. And let's be honest, you can't learn how to perform a delicate lab procedure just by looking at a diagram in a book. The real power of VR, and this is what gets educators so hopeful, is that it lets students actually do the thing. They can practice, they can mess up, they can try again, all without any real-world consequences.
And this all boils down to one magic word: embodiment. This is the secret sauce. It's that feeling of actually being there, that the virtual hands you see are your hands. The theory is that this deep physical feeling is what really cements the learning in your brain. But does it actually work that way?
Well, to find out, a team of researchers designed this really fantastic experiment. They decided, you know what, let's cut through all the hype and actually test this core assumption. Does more immersive, more embodied tech automatically mean better learning? And the skill they chose to teach was just perfect for this. They taught 177 high school students how to use a micropipette. And this is a great test case, because it's a real-world skill that needs two things. You need to know the steps, sure, but you also need the physical coordination to actually do it right. So, the researchers set up a test with two key variables. First up, immersion. One group got the full fancy VR treatment with a headset that completely blocked out the real world. The other group learned the exact same lesson, but just on a normal, flat, 2D computer screen. And the second variable was interactivity. The high interactivity group used controllers to actually mimic the hand motions of pipetting. Their virtual actions were what you'd call congruent with reality. Meanwhile, the low interactivity group just pointed and clicked with a virtual laser. Their actions were incidental. They had nothing to do with the real-life skill. And here's how that all breaks down. You basically get four groups. You've got the most basic setup, point and click on a PC, all the way up to the most advanced, mimicking gestures in a full VR headset. The whole idea was to see which one of these combinations, if any, actually produced the best real-world results. Now here's what makes this study so smart. The real test wasn't some multiple-choice quiz. No, it was a transfer test. After their virtual training, the students had to walk over to a real lab bench and actually perform the pipetting procedure with real equipment. Because that's the whole point, right? Can you actually apply what you've learned? Okay, so we've got this set up. 4 groups, 1 complex task, and 1 real-world test. Now, if you're like me, you'd probably bet that the most advanced, expensive tech would come out on top. But the results? Well, they were not what anyone expected. First, let's look at what the students felt. When asked about presence, that feeling of really being there, the VR groups scored way higher. So the tech definitely worked on that front. It felt more real. No surprise there. But feeling immersed is one thing. Actually performing the skill better is something else entirely. So the million-dollar question is, did that feeling of presence actually help them do better in the real lab? And here is the big twist. There was absolutely no significant difference in performance between any of the groups. Let me say that again. The students who learned on a simple desktop computer, just pointing and clicking, did just as well as the students in the fully immersive, super interactive VR setup. For anyone who's into stats, you can see the p-value here. A high number like this basically means the difference was nothing. It was statistically invisible. The fancy, expensive, immersive setup gave absolutely zero learning advantage for this task. Which leads to the obvious question: why? This is where we get into some really cool psychology, because this result isn't just a random fluke. There's a really solid theory that explains why more tech doesn't always mean more learning. And it all comes down to this idea called cognitive load. The best way to think about it is that your brain's working memory is kind of like a computer's RAM. It's got limited capacity. The actual stuff you're trying to learn takes up some of that RAM, but so does everything else. The user interface, figuring out the controls, any distractions, and that extra stuff is called extraneous load. And that's the leading theory for what happened here. The novelty of VR, getting used to the headset, learning the new controllers, all those cool features might have actually been a distraction. They might have created so much extra mental baggage that it canceled out any of the benefits of immersion, leaving less brain power for the actual lesson. The researchers who ran the study summed it up perfectly themselves. They said, the real challenge isn't just to make learning tech cool and engaging. The trick is to find that perfect balance, making it motivating, sure, but without overwhelming the student's brain with stuff that isn't essential to the lesson. So what's the big takeaway here for the future of VR in education? Well, it's definitely not that VR is useless, not at all. It just suggests that maybe we need to be a little bit smarter about how we design and use these tools. So let's just pull this all together. First, the good news. Learning in a simulation, whether it's VR or just a PC, really can transfer to the real world. That's huge. But the big lesson here is that more immersion and more interactivity don't automatically make it better. At the end of the day, good instructional design, the how of the teaching, is way more important than the fancy hardware you're using. And that leaves us with one final big question to think about. If shiny new technology isn't some magic bullet, then where should we be focusing our time and energy to actually improve how people learn? It's a great question. Thanks for joining me on The Explainer.